Hi, everybody. Welcome to Math with Ace, focusing on statistics. Today, we're going to be talking about experimental design. And experimental design is going to encompass the way in which we create experiments or we observe things, as well as some possible issues we might encounter, some key principles, things of that nature. It's going to be a brief overview of those items. So when we're talking about experimental design, how do you know whether something is an experiment versus an observation? When you have an observation, this is going to sound silly, you are observing things. You are looking at information and then using that to make decisions. In an experiment, you're not just observing or looking at data. What you're doing is you're imposing treatments. You are manipulating variables. What does imposing treatments or manipulating variables look like versus what does an observation look like? Let's say we are wondering whether chewing gum can improve test performance. And so if you were to observe, what you could do is you could go to a class. You should have some randomization. We'll talk about that later. But you could go to a class and you could ask people, did you chew gum? What was your grade? And then they would tell you yes or no, they chewed gum, and then they would tell you your grade, and then you could try and make some sort of relationship or correlation between the two. But you're just asking whether or not the person chewed gum. In an experiment, you are randomly assigning students to groups, and you're giving half of them gum and the other half not, and then you're measuring their results. So you are actually manipulating the variable by giving a treatment. You're imposing a piece of gum versus not a piece of gum. And so when you are doing that imposition of treatments, that is considered an experiment. You are putting tires on a car and you're monitoring the wear. You're deciding whether you give fertilizer or not to different plants. In an observation, you're asking or you're looking at the data and determining whether they meet your conditions or not, and using that to make a generalization. The key thing about experiments versus observations is that in an experiment, you're allowed to determine, or you're able to determine cause and effect from an experiment. You cannot do that from observations. There is no causation from observation. You can determine whether there is a relationship, but you cannot say one causes the other. So for instance, if I am to go to a farmer and say, did you use fertilizer? Did you not? And then measure growth and try and you could say there's a relationship between fertilizer and growth, but it's not until I design an experiment and I say, okay, half's going to get fertilizer, half's not, and then I'm going to measure and I'm going to be able to say, yes, fertilizer causes growth. It's not until I do an experiment that I'm allowed to use that cause and effect statement. Okay, you can determine relationships and association for observations, but causation comes only from experiments. When you are doing any sort of experimental design, it's very important that you include a few key principles, one being randomization. You need to either randomly assign the treatments or you need to use random assignments. You randomly sample into your groups. Typically, you are randomly assigning so that you can create groups that are similar to the population and eliminate bias. So you need some form of randomization. You cannot allow people to self-select. You also need replication. I went to, let's say I went to the grocery store and I ate a chicken breast, and then I went to the gym and I had my max bench press. So chicken breast causes me to max bench press, right? That happened the one time. Can I duplicate it? So you replicate things to make sure that what's happening is valid and it's not just a one-time thing. Could have happened one time by chance. Is it one time by chance, or is it a lot of times to show evidence? The replication is also really important. When you are dealing with experiments versus observations, we have something that we believe maybe impacts something else. We have an independent variable and a dependent variable. So we're using explanatory variables and response variables. And when you're analyzing the relationship, the explanatory variable is the variable that we manipulate, and the response variable is the thing that we measure. So we think that the explanatory variable is causing some sort of or impacting some sort of change in the response. The variable that is measured to determine a relationship. So if I'm talking about that fertilizer example again, I am using the fertilizer to determine whether I have growth of the plant that I'm dealing with. So the response variable that I'm measuring is the growth of the plant, and the explanatory in that case would be the fertilizer. So I'm giving fertilizer versus not fertilizer, and then I'm randomly assigning or randomly deciding who gets what, and then I'm measuring those results at the end. Now, when you're designing an experiment and you want to do just completely randomized design, what happens is you will have, let's say, two groups. You could have more than two treatments. You could do fertilizer, you could do not fertilizer. And let's say you're doing oven temperatures, you could do different levels of the temperatures. It just doesn't have to be like oven on versus off. So you could have more than two groups. But let's say in one group, I have random assignment. And they're getting these treatments. And then I'm going to measure the results. Okay, so let's say I have plants and I take 25 plants here and 25 plants here, and I use random assignment. I guess I could move this random assignment down here since they're both getting randomly assigned, but one group maybe has fertilizer and the other group has no fertilizer. And then what I do is you measure the response variable and you compare the results. The no fertilizer is considered our control. And that has no active treatments. Sometimes a control is a placebo. You often hear about the placebo effect. A placebo effect is when people are given the placebo and their symptoms improve or they get better, even though they had no active ingredient. So a placebo is a form of control. You can't just randomly sample plants, give them fertilizer, and say fertilizer causes growth without having something to compare it to. So control is like your baseline that allows you to have something to compare to when you're measuring your results at the end. You need that option. Now, when you are doing your explanatory and your response and you're designing your experiments, it's important to consider the fact that there might be some other variables that you might want to consider that could possibly be lurking in the background and possibly confound your study. So lurking variables are variables that exist in the background that you haven't considered in the study. Confounding variables are variables that make you unable to differentiate whether it was the confounding variable or the response variable that caused the chain or caused the change in the response. Let's see what that might look like. Let's design a study where we're using this fertilizer and we are dealing with plants and growth. And so what we've done is we have these plants. Let's say we have 100 plants. And we decide that we have some grassy fields where we're going to plant, but we've also built a shed where maybe we want to have our plants. So let's say I put 50 plants in here and I put 50 plants out here. Those are my terrible sun rays. But outside, we have the sun and these 50 plants, and then inside we have these other 50 plants, and we give all of the fertilizer outside and then no fertilizer inside. And over the season, we then measure the plants at the end, and lo and behold, the ones that are outside in the sun and have fertilizer have grown. So first of all, the explanatory variable is the fertilizer. That's the thing I'm manipulating. I'm giving some fertilizer and some not. And the response variable, again, is that growth that I'm measuring. So is it the fertilizer that caused my plants to grow, or is there something else that might be causing the plants to grow? Well, if you garden at all, hopefully you know that sun exposure does have impact on the plants that are growing. And so I don't know whether it was the fertilizer or the sun that was causing my plants to grow or that was impacting the response variable. So that sun is a confounding variable. And if I wanted to design a study where I was using my shed and I was also planting outside, what I could do is I could then say, okay, I'm going to have inside my shed, I'm going to have 25 plants that have fertilizer and 25 plants that have no fertilizer. So I'm using both my treatment and my control in that same environment. And then outside, I'm going to have 25 plants that have fertilizer and 25 plants that have no fertilizer. And so both of those situations are outside as well. And so what I'm doing is I'm creating a system where I'm eliminating that confounding variable because I'm looking at both inside and outside the shed, fertilizer and non-fertilizer. I am blocking to control for that. Now, there are blocks, as I've mentioned. Blocking is creating groups that you think might have some sort of effect in a study. So for instance, let's say we're studying metabolism and you think that genders might impact how people react to the medicine and the metabolic information. And so what you would want to do is you would want to block based on that grouping. A few more things we want to consider in experimental design is blinding. And blinding in a study depends on, there's a single blind versus a double blind, or no blinding. And most often, single and double blinds deal with when you have individuals as your subjects and you are measuring something that might be up to judgment. Somebody's height and somebody's weight is not a judgment call. Those are specific values that aren't going to change depending on who knows whether you're measuring this person's height or not. But if I'm measuring somebody's mood, I might be impacted by the fact of whether I knew that they had taken the medicine that was active or the placebo. And so when you are measuring something that might be left up to a judgment call or is might have a different perspective based on the information that person has, we use blinding in a study. And in a lot of medical studies, they use blinding to help make sure you are they're impartial and these the results can be generalized to an audience that it's valid, makes the study valid. So a single blind is when the individual receiving the treatment does not know which treatment they are receiving. Let's say I am part of a drug trial for depression. And if I know I'm receiving the active ingredient, maybe I think I am happier than normal. Whereas if I had the placebo, maybe I wouldn't feel that way. And so that would be a situation where you would want a single blind, and I wouldn't want to know whether I received the active ingredient or not, because I want my reactions or the way that I'm feeling to be impartial. A double blind is when both the individual receiving the treatment and the individual administering the treatment do not know which treatment is being given. Going back to the depression trial, I wouldn't want to know as the patient, because I wouldn't want that when you're rating, like, how do you feel? You wouldn't want to have some sort of biased response. And the person who's measuring the affect or the way that the person is reacting, you wouldn't want them to know and be biased to, well, I know that they got the treatment, so I'd see that they're happier. If you feel like going back into maybe 20 years of TV, Grey's Anatomy, which is still on the air, had an episode or had a series where the neurologist was doing a drug study on Alzheimer's. And the person receiving the treatment, the patient did not know whether they were receiving the active Alzheimer's treatment or not. And the doctors that were giving did not know either. And then it was a whole scandal because one of the characters went and found out and switched. And so that would have invalidated the study and would have put the medicine years behind had that happened in real life. So the FDA has really strict regulations on the way that studies can be created and performed so that we can actually use the results. We have a really strict regulations in the US. Hopefully this information helped determine explanatory response, single blind, double blind, helped give you some vocabulary information and how you can differentiate between whether something's an observation versus an experiment. And if you have any questions, as always, feel free to hit me up.